Hi, everyone. Yesterday, I did finish sewing the snows on this because there's like literally one stitch left. So now it looks like this. It looks even more like a tiny elephant right now. But today we're going to make the arms. I forgot that this technically doesn't have legs, it just has like a stem. And I wanted to tell you about dark energy, which I just learned about. I knew there was dark matter, but recently I started learning about dark energy. If you don't know what that is, we don't either. Basically, universe is expanding, space is expanding as we're inside of it, and it's accelerating. So, as we know, you need energy to make something go fast. If you don't have a lot of energy, something will only go slow, which means there's some kind of energy that's making the universe accelerate more quickly, and we don't know what it is. Isn't that interesting? With the knowledge that we have now, it looks like at the start of the universe, everything was just kind of like things were more uniform. Everything was kind of like just sand floating in water. But then there were always some small irregularities that just happens, that just is. So some small clumps of matter, they exerted more gravity than the matter around it. If you don't know something that's more massive, not necessarily heavier, because in space there's technically no weight, but something that has more mass in it, that will exert more gravity than something that has less mass. So, as space is expanding, generally speaking, things are moving away from each other, but there are also little clumps of matter that pull more on what's around them than the other clumps because the other clumps are smaller. So some clumps held on to each other more tightly than others. And then because they kept getting bigger, they just kept exerting more mass. And so eventually things kind of collected into clusters and superclusters and structures that look kind of like threads or hairs. That's how we got the structure of the universe that we have today, which if you don't know, it's sort of like it's sort of like the inside of a sponge. You know how there's like sponges are filled with holes, but there's also a lot of solid stuff. That's kind of what it's like. Matter isn't distributed perfectly evenly. There's clusters of galaxies, and those are collected even into even bigger structures called superclusters. Between them, there's a lot of empty space. Even even within those superclusters, it seems like there's a lot more dark matter than there is luminous matter. So there's a lot of stuff that we can't see, and what we can see is only a small portion of it. Isn't that interesting? During the early part of the universe's formation, it looks like things were a lot busier and more like cosmically active than they were now. Because imagine the Big Bang, imagine a big explosion of matter. So when things are moving very quickly, when particles are moving very quickly, that creates a lot of heat. There's a lot of collisions. Molecules are just slamming into each other all over the place. So stars probably moved a lot more quickly. They probably made black holes a lot more quickly. Those created quasars a lot more quickly. And so a lot of stuff like formed and deformed relatively fast compared to today. And what we have now, where we have a lot of elliptical galaxies, a lot of those are very old, which is why they look more reddish. A lot of old big stars that have kind of cooled down physically and metaphorically, they look more of a reddish orange or an orangey yellow. Okay. First arm done. These are nice and small, so they shouldn't take long. Oh, we gotta make two. I don't think I've explained what a quasar is. And if I'm understanding everything right, their name comes from like a quasi star-like object. Because when we first saw them, we saw like an object far, far away that glowed like a star, and it's really bright like a star. From far away, it just kind of looks like a star, but it's not a star. And I don't know a ton about these, so I don't want to go into too much detail in case I get it wrong. But I think what happens is they start with a black hole. So, black hole, super, super, super massive. And once you get to the event horizon, which is the place, it's like a field around the black hole where it starts sucking in matter and space time gets all weird and you start turning into spaghetti. Um, stuff starts kind of circling it. You know how when you like the toilet or you have like a drain, it's like stuff like circles around before it goes into the drain. It's like that. So matter will start streaming into the black hole after circling around it for a while. And the kind of circular field of matter that's circling around the black hole is called an accretion disk. And because black holes are so, so big and the force that they exert on other matter is so strong, stuff is moving around at an incredibly fast rate, especially as you get closer to it. And that makes it very, very hot. So that's why we can see all this stuff happening all the way from Earth. That's why these objects look like stars from far, far away. They're moving so quickly that they get super hot and bright. Like, I've never moved something quickly enough to see this, but I've heard that if you like you turn metal really, really fast, not only does it get hotter, it starts to glow a little bit. I think that's dangerous. Don't do that just for fun. Additionally, as stuff is falling into the black hole, not all of it gets in, some of it gets spit back out. You know, when a small child is like first starting to learn to eat and they kind of spit a bunch of stuff out because they're little and don't really know how to control their motor skills, it's kind of like that. And the stuff that gets flung back out of the black hole it's called like jets. And those tend to go perpendicular to the black hole, which are also so hot and bright that we can kind of see them from Earth. Some elliptical galaxies are so old. When we look at them, we're looking super far back in time. When we look at stars, we're technically looking back in time because it takes so long for their light to reach us. But like I was going over yesterday, if you were here yesterday, you probably heard there are some galaxies that we can look at and go, wow, so that's what the universe was like when it was less than 1 billion years old, which in astronomical terms is a baby. Isn't that amazing? I think the Milky Way is on like the edge of the Virgo supercluster. Virgo's a constellation, obviously. The supercluster is a cluster of clusters of galaxies that is found in the Virgo constellation. If you don't know, galaxies aren't just like sitting by themselves in the universe, they're drawn into clusters. So there'll be like one galaxy here, one galaxy here. They're all gathered into a little like neighborhood. And then that kind of celestial neighborhood, the supercluster it's in, where there's cluster here, cluster here, cluster here, cluster here. That's kind of like the city or the town that the neighborhood is in. Tying this off real quick. These I need to sew to the front of the body, but I want to make sure I get them in the right place. So I'm going to have to check the pattern for a minute. Looks like it's on the sides. Hold on. They know that I need to have the little hands folded in the front. Usually what I do is start by pinning something kind of randomly, and then I adjust it till it's where I want it to be. Takes a lot of the pressure off. Boop, look, hold hands. Boop. Okay, I don't know if I'll sew the hands together actually, because I like being able to move them around, but if it gets important later, we'll see. I think next we start on the flower, which is very exciting. I know some of the stories behind what other cultures have for the Milky Way, but I'm curious about what they call it. Because in like the Anglosphere, we call it the Milky Way because it looks kind of like spilled milk. Like if you just had milk and you like spilled it. I don't like that. I think that's kind of weird. Like it does look kind of like spilled milk, but come on, is there nothing else you could compare it to? I think I've seen some people call it like a star river, and that's really beautiful to me. Like was the only explanation you could really think of that Zeus has baby Hercules and he knows Hera doesn't like him. So while Hera is sleeping, he sticks Hercules onto Hera's chesticle and has him try to nurse. But Hera doesn't like that, so she wakes up and just smacks him away, and the milk just sprays all over the sky. Like, how do you come up with that? I wouldn't have thought of that. I would have thought of a river first. Okay, so next we need to get out the green to start making the flower center. Here's our little creature so far. And now it continues to look very strange, but eventually it will look cute. I don't think I've used this green before, so we should have plenty of it. I'm sorry I keep putting this in front of the camera. It's just it's just the setup I have right now. Okay, 6 single crochet in a magic green. There's so many weird things Zeus has done. If you know anything about Greek mythology, you know. It's just like adding to the list. Why would you attach like a baby to someone's chesticle while they're sleeping? That's weird. They don't know that's happening. They didn't decide to feed the baby. 3, 4, 6, 10. The Milky Way also looks kind of like a cloud. There are a lot of things that look kind of like clouds in the universe, so I might have called it like a sparkly cloud first. I definitely would not have gone spilled milk. Maybe someone just really liked milk. I don't know. Something I didn't know until kind of recently was that spiral galaxies, which a lot of us probably know about by now. They're just galaxies in the shape of spirals. Was for a while people thought those were just like nebulae, spiral nebulae, until people started studying them and went, no, actually, these are completely other galaxies. Or do you know about parallax? That's the apparent change in position of something when you're far away from it. It's kind of hard to explain without a picture, but like, um, if you're really far away from something, not only does it look like smaller, but imagine you're looking at like a house across the road. If you move to the left, it'll look like the house moved to your right. Obviously, it didn't. That's just how our eyes work. That's just how perspective works. But that's how it looks. Meanwhile, if you were looking at the house from like multiple streets away, you could somehow still see it and you moved to your left, it would look like the house barely moved at all. So we can measure that with the stars. The stars do appear to move in position depending on where you're studying them from. Yes, they also move through the sky. That's a whole other thing. But something I didn't know was in ancient Greece, people like noticed that and they thought like, pshaw, there's no way. Because the star's parallax is very, very small. They do appear to move in position, their apparent position moves, but it's a tiny, tiny, tiny amount because the stars are so far away, it almost doesn't make a difference. Now, at the time in like ancient Greece, people didn't know that the universe was as big as it was. And accounting for such a small parallax would mean, wow, those stars are incredibly, incredibly, incredibly far away from us. That means the universe is way bigger than we thought it was. At the time, people weren't really ready to make that leap. They were like, there's no way the universe is that big. So they were like, well, we're just surrounded by spheres or whatever. And the spheres rotate and the stars move on those, which obviously they don't. We know that now. But it was interesting to learn to me because I think it shows how people can get like bogged down by their expectations. Like it's hard to comprehend how big the universe is and it's still expanding, but it's big. It's bigger than we thought it was. It just is. Even if we don't understand it that well, here it is. There's no getting around it. And I think that's important to remember in astronomy, but also in all the sciences. Like, even if it seems weird at first to imagine that there's some kind of energy making the universe go faster, or there's some kind of matter that makes up most of the galaxies, like, even if you didn't consider that before, it might just be there. And if what you do is like, I pretend I do not see it, then you're pretending, you're lying, you're not being honest. I don't know a ton about it, but I think the term black hole wasn't like popularized until the 1960s, which surprised me. I thought it was much older. Like there have been ideas about very massive objects in the universe, but until really recently, we didn't know exactly what they were. And I think I remember when we got like the first real picture of a black hole, like obviously you can't really see a black hole, but you know, the kind of first picture where you can see like the ring of orange and there's like a circle of black in the middle. I remember that. That was so cool. And that happened in my lifetime. Like we're just finding this stuff out. I don't think I've ever made a flower like this before, but it looks really fun. Something else I find really interesting is the laws of orbit. I think, I don't know if everyone knows this. So, a lot of times in pictures, the planets' orbits will be drawn as circles. And that's just so they can all like fit on the same page and because humans understand circles well. But if you measure this from like with big math and exact calculations, they're not exact circles, they're ellipses. And that's like an oval. That's a shape that's not quite a circle. And the level to which it's like stretched or squashed or otherwise changed from being a circle, that's called its eccentricity, the level of which it's eccentric. The farther away a planet is from the sun, also, the slower it moves. So again, a lot of times in like simple simulations, planets will be drawn going at a constant speed, and that's just so we can understand it, okay? But actually, what happens is planets, as they're closer to the sun, they move more quickly because the sun is so big, it's pulling on them more. Its gravity is pulling onto the planet, and that means it moves faster. But as the planet gets farther away, sun's gravity can't reach it that much, so it moves more slowly. Something I didn't know until recently was that Mars is really small. From like a planetary perspective, I think it's about half the size of Earth. Just because it's similar to Earth in a lot of ways. For some reason, I thought it was around the same size, and it's really not. Venus is, but it's very, very different. It's very hot. It's very cloudy. It's very toxic. Ironic for a planet named after the goddess of love. I wonder if the search for life on Mars is not just about like evidence of life, because we know there's like rust. We know there was like probably oxygen, for example, but I think it's not just like evidence of microbes that people are looking for, although that's super cool. Don't get me wrong, that's super important. I wonder if people are also looking for really complicated, intelligent creatures like humans or animals. I was in a science class recently that went over theories about the origins of life and how that might have to do with geology. And this wasn't something I had ever really considered before, but it brought up something that's very true, which is we technically have rocks in our body. Like our teeth and bones, those are made up of the same things as a lot of rocks, like calcium. And some shells are made of like, I don't know the technical name of every chemical. There'll be like lime, more calcium, a lot of the same stuff that makes up rocks and sediment. And so some people are theorizing now that life in rocks maybe didn't develop separately. Maybe they actually helped each other. Like things just got more and more complicated, and some of the things ended up being alive, like carbon, which you see in living organisms, you can also find in like coal, obviously. And I think that's important because again, like in grade school, a lot of things are presented in a lot of in a very simple way, just so we can understand them better. But in real science, in the real world, things aren't that simple, and we shouldn't expect them to be. I feel like logically that makes sense, but it's easy to forget if you don't actively remind yourself, because it always doesn't always come up in real life. Like not everyone becomes a scientist, but all this stuff is still true. For example, when we quote unquote demoted Pluto to a dwarf planet, nothing changed about Pluto. And the scientific definition of a planet doesn't really make any sense and isn't really consistent, which is crazy and is a whole other headache. It's like things just exist, and a lot of times people will categorize them because that helps us understand them, like rocks and living things. But there aren't necessarily like actual boundaries between those things in nature. We have rocks in our bodies. Lots of living things are partly made of technically rocks. Sometimes they become fossils and turn back into rocks. Look, it's going to be the bottom part of the flower. So we're going to put the center part here and then the petals around it. It's going to look so cute. I forget which rock it is. I should study it again. But there's one kind of rock that's like, well, I think it hardens into rock, but there's one kind of thing that's so fine. I think it's either slate or shale. And there's clay too. That's so fine. It's really, really good at preserving fossils. So when we look at it, we can find preserved fossils from millions and millions of years ago that wouldn't survive in other kinds of the ground. Isn't that cool? It's really cool to me how many different kinds of rock volcanoes make too. I don't know all of them, but I really want to study them. Like it can make glass that's so thin and looks like individual hairs, so it's called Pele's hair after the goddess of volcanoes. Or it can create obsidian, or it can create snowflake obsidian. Almost done with this part. We know ginkgo trees are older than both flowers and fruits, which is crazy. Like, those seem pretty normal to a lot of humans, but they're a concept that's relatively young, like from a geological standpoint. So we want to know, what did everything look like when ginkgos were first forming? What did some of the first flowers look like? What were the first fruits like? What was happening? How did they develop? Okay, now we're going to get out the yellow and start making the center. I could have tied that off more neatly, but oh well. Did I tell you guys, magnolias originally evolved to be pollinated by a kind of beetle? Isn't that interesting? I don't know that much about them, but I know they're also like a super old kind of flower. So that's something I really want to know more about. Like if we go back hundreds of millions of years, could we see these same kinds of trees as we have today with the big waxy leaves and the giant beautiful flowers? Did they look different then? Was there a long enough time between then and now for them to have evolved? I want to say pine cones are super old too, but I don't know that much about them. I feel like I used to know why things were so much bigger in like prehistoric times, but I think I've forgotten. So it's something I want to research. Like, why were there giant dragonflies? Why were most dinosaurs so big? A meganora. When I was a little kid, I didn't know that saber-toothed tiger's like scientific name was the Smilodon. And when I found that out, I thought it was really funny because that makes it sound like it's always smiling, and it's not, but it does have very big teeth. 6. I want to know when insects came around too, because I know very little about them. Like, obviously, they were there a long, long time ago because there were giant dragonflies, but when did they first start out? When did things just get really small and develop exoskeletons, or were they like some of the earlier creatures? Do we know for sure? I don't know. I don't know. It's also really interesting to me how we can find so many of the same metals that we have on Earth, just all over the galaxy. Like everything is in the whole universe, everything is made of the same like building blocks. That's insanely cool to me. Like you can find iron in a lot of asteroids. Eventually, stars start making it. That's why I think the periodic table of elements is so cool. Like it's shaped kind of like building blocks. Everything in it is like the building blocks that you use to make up everything else. This shouldn't take too long. So this says once we're done making the center, we gotta stuff it a little bit. We start sewing this onto the green part, we stuff it a little, so it's 3D, and then we sew it closed. How did pollen develop? How did bees start like carrying it around? That's another way to visualize the structure of the universe. It's sort of like a honeycomb. If you've ever looked at the inside of one and it's got like the hexagons everywhere, it's sort of like the clusters and superclusters are those hexagons, or like Swiss cheese, where there's little clusters of holes scattered around it. I was a little surprised to learn too that a lot of stars come in binary systems. A lot of stars will orbit each other. Well, not technically. There's two stars that are like together and they're both orbiting the same center of gravity. Our sun is kind of an outlier there. Stars are interesting to me because they're always creating stuff, at least for a while anyway. They're making an element out of another element. They're very active. They do stuff, kind of like a machine. As a little kid, I obviously didn't know that. But now I think it's really cool because they're always producing something. I don't know it super well right now either, but now I know there's a few different kinds of supernova, and not every star like goes supernova. So that's something I want to like keep studying until I get it. It was also funny to learn that some of the structures in the galaxy, the actual technical term for them is irregularly shaped blobs. That's exactly what they are. They're blobs and they're irregularly shaped, but I thought they'd have like a more specific name. I also learned that some objects are called wimps or machos, depending on what they are. And I don't know them super well, so we can't really describe them that much. Like, astronomy is super cool. There's just so much material that sometimes I have to read something like 3 times to make sure it sinks in. There's just so much to learn. But I find this funny because for a long time, and this wasn't entirely fair of me. This was just like the impression I got from media. I kind of thought that being a scientist meant you had to be like serious all the time. But the more I learn about it, the more it seems that scientists are like intentionally having fun with their names for things like eggs, wimps, machos, irregularly shaped blobs are all actual scientific names for things in the galaxy. Not just in the galaxy, the universe. I just talk about our galaxy a lot. And also, some galaxies are called galactic cannibals. That's where I'm like, guys, chill. But it's also just really fun and makes me laugh. So I think this must be something that people like really enjoy and they love to talk about. Okay, now I should probably pin this a little. This needs to be okay. We're sewing this to row 5 of the bottom. 1, 2, 3, 4, 5. Okay, I wonder if I should sew this with green actually, because the yellow is going to stick out. Hold on. It's cool how the word astronaut means star sailor. That's not exactly what you're doing, but it does feel kind of like the sea. So I might research some more words that mean similar things, but in the story idea I have that's about like sailing in the sky, I might name it something like that to show that you're exploring both. So you don't have to completely cover up the green part of this, see? Because we're sewing it to row 5. That's interesting. I wonder if that's meant to represent like the I think it's called the sepal, the green part of a flower that's just there, but we might also cover this up with the petals, so I'll see. Why is it called the Milky Way too? Why did we call it that? Did we think it looked like a road? I guess it does kind of look like a road, but I wouldn't have called it like a road and also milky. I would have called it like the path of stars. Oops. I didn't plan this, but there's a character that I created who I want to represent like nighttime and the stars in her story world. And the more I think about it, the more I think one of the influences for her might have been Rosalina from Super Mario Galaxy, because she's a character that I really liked and that made a real impression on me as a kid. I wonder why she's named that too, because it makes me think of obviously roses, earth plants, but she's very clearly a character that doesn't live on Earth. She lives in space. I would have named her something to do with like the stars. And this isn't like a criticism, I just find it interesting. We're going to start stuffing this soon. It's like a little pocket. It almost reminds me of a ravioli. I wonder if we've discovered whether pocket dimensions are real in real life. Because when we talk about dimensions, we're not really talking about like a whole separate plane of existence. We're just talking about like up, down, left, right, flat or not, 3D or 2D. So I almost wonder where that came from. Gotta fix this real quick. Did I put the stuffing away again? Hold on. I put it away because I don't want my cats to play with it. They like to play with crinkly plastic things, but which the bag is, but I'm concerned they'll like eat it. Okay, let's start stuffing the ravioli with cheese. Does that look Should I stuff it a little more? That looks better. I wanna pin this in place so I can sew it on evenly. Isn't it something that's really interesting to me about astronomy is how we can learn stuff by understanding that we don't know stuff. Like, for a long time, we knew that the orbit of Uranus didn't match up exactly with what our calculations about, like, the rotation of the planets and Kepler's laws of planetary motion and stuff said it should be. It's a bit of a long story. But for a little while, people were kind of concerned, like, does that mean the laws are wrong? And no, it looks like the laws are right, but there is something exerting a gravitational force on Uranus that we hadn't discovered yet. And that obviously turned out to be another planet, which was Neptune. Isn't that interesting? We couldn't see it for a long, long time, but we knew something was out there. So we just kept looking for it and looking for it and looking for it until we found it. That's what a lot of stuff is with like dark matter. We know something's out there, we don't know what it is. So we're going to keep exploring it until we understand it better. I keep getting my working thread tied around my pins because I'm clumsy. I don't know a ton about it yet, but today I was reading about like particles that flicker in and out of existence, and that sounds insanely cool. So I want to see what else I can learn about that. To look for neutrinos, people had to get like giant tanks of cleaning fluid, not even like a telescope. So it was a detection method I had never considered in my life. It's kind of funny to me to imagine someone walking in who doesn't know what all these fancy astronomers are doing and being like, "Why do you have giant vats of cleaning fluid? What are you doing?" And they're like, "We're looking for a kind of particle that we're pretty sure exists. It's just so small you can't detect it normally." And it's like technically part of antimatter. Like, isn't that crazy? It worked. It ended up a little wonky, but here's the center so far. A lot of real life flower centers aren't very perfect either. Okay, that's a bit better. Gonna tie this off now. Next, we make the petals, and we're gonna make 5. I wanted to make the white flower Flabebe, but obviously most of the body's cream, so I'm hoping that stands out okay. There. Look, it does look like a little ravioli. It's even got like it's got the scallops around the edges. We will definitely not make all of the petals today. I want to get started on one just to see what it's like, but we might not finish it. Okay. Three, four, five, six. I remember once my mom was looking at a comparison of like planetary sizes and rotation speeds. She finds out about Jupiter being utterly massive and just rotating super slowly. And she's like, what is going on? And I was like, well, if Jupiter had been any bigger, it probably would have been a star. And then there would be no Earth because there would just be like way too much heat for there to be a Goldilocks zone. It's interesting learning about how things just regularly like fall into Jupiter or hit Jupiter and make little dimples in the atmosphere. And they just kind of fade away. Like that's just a thing that happens. It doesn't have impact craters like the moon because lots of gas. Well, it's technically liquid, but it's a gas planet. And that's just a thing. Or how the Great Red Spot, very imaginatively named, is like dissipating. It's a storm, and the storm is kind of blowing itself out. I think we still don't know why Uranus, I'm pretty sure, is the one that rotates on its side. I think we still don't know why it does that. And the like leading theory right now is something knocked into it, just kind of knocked it on its side and then it just stayed like that, which makes sense to me, but we still don't know. So I really hope we find that out one day. And that reminds me of another interesting thing about how the universe kind of settled into its current shape. So the leading idea we have right now, remember how when things formed in the universe it was probably really hot, things were moving around at top speed and just slamming into each other. Well, as things collected into clusters due to their bigger gravity, they're moving less because gravity is holding them in place. And that creates a kind of feedback where because things are moving around less, they slow down and they get colder. And then because there's less heat making things move around, like the particles that were already moving, they stop heating up other particles, so those stop moving too. And everything just starts kind of cooling down and settling and getting calmer. It's sort of like something freezing. Like imagine if you had like a lake that was normally tossed by wind, but then even though there's like fish getting tossed around, there's leaves, there's sticks. Imagine if it all froze. Then everything would just be frozen in the position that it was when everything cooled down. And that seems to have been what happened to the universe. Like things formed into clusters and superclusters. And because of their gravity holding things in place, that started the cooling down feedback loop, and things just kind of settled. That's not to say there's nothing happening at all. There's still like activity happening everywhere. It's just like it's not as crazy as it was when the universe was very young. It looks like we're going to be working in the round. We're going to be making a kind of petal shape. So it's going to be like we're making a 3D shape that normally you would stuff, but instead we're going to flatten it. Making sure I have all the numbers right. It's a little interesting to me that parts of the spiral galaxy are called the arms, I would have called them like spokes, like in a wheel. And that's not like a bad thing. It just makes them sound like they're alive. And I wonder if people do that because it makes them easier to understand, like saying a black hole eats other things or that galaxies eat other galaxies, sort of like animals do to each other. Like saying a star has a life cycle, for example. A star isn't alive, it's a process. It's a process that runs on a bunch of smaller processes. But it's sort of like a lifestyle where like it forms and it produces a bunch of stuff and then eventually it runs out of energy and it dies. I'm kind of curious about what different people thought the stars were, different like stories about the stars. Because obviously you know like the scientific explanation now, but like if you saw tiny points of light from far, far away, what would you think they were? To me, they look almost like jewels. Yeah, see, you can squish this like this. So once it gets bigger, like once this beside the petal needs to be, we'll just flatten it and like sew and crochet around the edge. Once we're done this row, I think we'll be done for today. Okay, and that should be all. We've made some pretty good progress. I don't know if I'll stream again tomorrow exactly. I'm still figuring out what I want to do, but I will be back very soon.